Hi there, welcome back to the channel. In this video, we are going to be talking about ATP disintegration or ATP degradation. You see, ATP is a molecule that is known as the energy currency of the cell, and that is because it is involved in various biomolecular reactions that occur in the cell, especially the ones that have to do with energy. And that is because it is a high energy molecule. And in fact, if you see the structure of ATP, you're going to see that it is really a high energy molecule, because ATP, you would normally see ATP written as like this. You see ATP written as ATP4 minus, and that is to tell you that it has 4 negative charges close together, and then these 4 negative charges are still held together. I mean, they are close to one another, yet they are not separated. So although that is one of the reasons why the reactions with ATP is spontaneous, but at the end of the day, it shows you how much amount of energy is needed to bring together these negative charges so that there is no separation. Is that okay? So now, how does the ATP works? ATP is termed adenosine triphosphate, and quickly I'm going to be drawing the structure that looks like this, the structure of ATP. So you have this. So this moiety here, this moiety you're looking at here is called adenosine. And why is it called adenosine? Because so there's a CH2OH here, is that okay? So CH2OH, that is adenosine, and that is why, which is because this guy here is called adenine, which is a nitrogenous base, and because adenine is bonded with a ribose sugar, so it is a coinage of adenosine. The word adenosine is a coinage of osine, meaning sugar, and adenine, meaning the nitrogenous base, the pyrimidine adenine. So that is the combination of adenine and ribose is what gives rise to adenosine. Now, triphosphate comes from when this guy has attached to it 3 phosphate groups. So you're going to have a phosphate group, another phosphate group, another phosphate group. So we have something like this. All right, so this is why you have ATP4 minus. Why? Because you have 1, 2, 3, 4 negative charges. So how are these bonds? How is this bond even existing? It is what tells us that this guy has what is a high energy molecule, and that is why when this guy breaks, it begins what at a high energy and what ends up what in a lower energy, and that's the reason for, in fact, its disintegration in the first place. It has to disintegrate because it is a high energy molecule. So it wants to attain a state of lower energy. So what does it do? It does what? It breaks down. So it begins with the high energy and then reaches its activation complex and then begins to come down. So you notice that at the end of the day, it ends in an energy level that's lower than it started. So here we have our free energy. So, and the change in Gibbs-free energy for this reaction is less than 0. So, which means what? It's a spontaneous reaction. It happens on its own in the cell. Now, how does this reaction occur? It actually occurs in the presence of water, so that this guy is going to attack one of the reaction is called a nucleophilic reaction. So it's a nucleophilic attack where this guy is going to, one of the molecules is going to be attacked by a water molecule, and OH group is going to bond to this guy. Now you ask yourself, because this guy is negative, this guy OH minus is negative, why? How is it that it is not? The molecule is the total molecule here is partially negatively charged. Why? Because this oxygen has a higher electronegativity value, so it's going to draw electrons to itself. So this guy is actually going to what? Electronegative. So like it's going to be overall electronegative, or have a partial negative charge. So because of that, it's supposed to be repelled by these negative charges, because of law of electrodynamics, or electrostatics rather, says that what? Like poles what? Should repel. But why is this guy, how is this guy able to penetrate that center now? What happens is that during the time of the reaction, there is a a short time, or you say a short-term protonation of these charges, or we simply say by an enzyme called ATPase. So we simply say that this enzyme ATPase keeps these guys busy by partially, temporarily, that's what I was looking for, by temporarily protonating them. So when they are partially temporarily protonated, at that time they are unable to what? To restrict the negative charge that's coming to what? To attack. So because of that, the negative charge is able to attack, and then we started off with ATP. So at the end of the day, we're going to get what? Become what? ADP 3 minus. 3 minus because one of these guys is going to be lost. So we have H3PO4 lost, and then these two phosphate groups are still available. So this happened via following a what? A loss of phosphate group. So this is the first step in the disintegration or degradation of ATP. Now, why does this even happen? Is either because we want to generate energy, or it also happens when the animal dies. For example, when fish or any other animal dies anyways, in the cell of that organism, the ATP that is available there is going to spontaneously, I told us it's a spontaneous reaction, so it's going to spontaneously disintegrate by itself. All right, so because it's a high energy molecule, it cannot remain in that high energy state even at the death of that animal. So it's going to what? It's going to disintegrate by itself. So we're going to lose a phosphate group here and then become what? ADP. Now, on further disintegration, what will happen? We're going to lose another phosphate group. And when we lose another phosphate group, we call what? AMP. So ADP stands for what? Diphosphate. 2 phosphate. AMP stands for what? Monophosphate. 1 phosphate group. Now, at the end of the day, this reaction will still further by losing the last phosphate group, in fact, and when we lose that, we become what? A, which is also just what? Adenosine. So meaning that it's going to remain only this moiety that we started with. So, and this is also following what? The release of what? The loss of 1 phosphate group. We lost phosphate group in the entire process. We lost phosphate group in the entire process. So we lost the 3 phosphate groups. Now, because the organism is dead, there is another process that could follow, the loss of an amine group. So when an amine group is lost, the process is known as deamination. So following deamination, we could lose NH3 here. So when we lose NH3 here, we are going to form what is known as, how do we draw that now? What is known as ITP. So these could simultaneously lose amine group and then become what? ITP. ITP stands for inosine monophosphate. ITP standing for what? Inosine triphosphate rather. Inosine triphosphate. So what is inosine? So inosine is basically the product of what? The deamination of adenosine. And what do we have? We have this structure. So we still have our ribose sugar. Now, because of triphosphate, so let's assume this 3-phosphate group is still here. Now, what you will now see, the essential difference is in this adenine molecule. Adenine molecule changes, and then we have something that looks like this. So, at here, we're going to have something that looks like this. So what happens? You're going to see that this guy is now bonded to what? It has a double bond that extends to what? To oxygen. So this molecule here is what you call, together here, you call this inosine. You call this moiety inosine. But at the end of the day, now, because of triphosphate, you have what? Inosine triphosphate. Now, that process could further occur where this guy, it could happen to this guy, where this guy will lose what? An amine group. So when this guy loses amine group, what does it become? It becomes what? IDP. Or this guy loses amine group. So when he loses amine group, what does it become? It becomes what? IMP. Is that okay? So when the last phosphate group is lost, then what does this guy become? It becomes what? Inosine. So the same way we either will adenosine here, we're going to what? Inosine there. And then when inosine becomes disjointed from its ribose sugar, when it loses this ribose moiety, so what happens is that inosine becomes what is known as hypoxanthine. And this is the cause of fouling. This is the cause of fouling. I'm going to write it here. Hypoxanthine. So this is what causes fouling in dead organisms. So you begin to perceive smell. It's called, these are metabolites that degenerate from spoilage of organisms. So this one basically is associated with what? The disintegration of ATP. So there are certain metabolites that are formed at the end of the day when an organism dies, and then of course all those other cellular components, cellular biochemicals are disintegrating and getting putrefied. You know, they are metabolites that are formed. So here, this hypoxanthine is formed at the end of the day when this guy disintegrates, and it proliferates easily. So when on proliferation, it becomes very abundant, and then what? You begin to perceive what? Very foul smells. So this guy alone is what you call what? Hypoxanthine. So notice hypoxanthine is just, inosine is what? Hypoxanthine plus ribose sugar. So without the ribose sugar, this guy is what? Hypoxanthine. So and this is the simple analysis of, analysis now, the breakdown of how ATP gets degraded in the cell of a dead organism. If you did gain value from this video, do well to subscribe to the channel and click on the bell notification to be notified whenever I drop a new video, and do share this content with your friends. And if you have any questions, drop them in the comment section below. I'm going to answer them as soon as possible. And do like this video as well. And God bless you as you do so.